Good afternoon, all. Welcome to I Square Maths Academy, where numbers and variables actually meet mastery. Today, we are going to be looking at differential equations. Yes, first order differential equation. And we're going to start by looking at the definition of a differential equation. Now, what is a differential equation? Yes, a differential equation is a relationship between an independent variable, an independent variable x, and a dependent variable y, and other derivatives of y with respect to x. E.g., we have x squared. The y all over the x is equal to sine x plus 4. Yes, now let me take it again. A differential equation is a relationship between an independent variable x and a dependent variable y and other derivatives of y with respect to x. Now, this is an example. Yes, when you have x squared, you have the derivative of y with respect to x and other functions. Yes, so today we are going to be looking at the different methods of solving or analyzing a differential equation. So now let's look at methods of solving. Yes, methods of solving an ordinary differential equation. Yes, methods of solving an ordinary differential equation. Now, method number one, we have by separating variables. Yes, that's method number one. Now, method number two, we have by direct integration. Yes, by direct integration. Then number three, we have by using integrating factor. Yes, by using integrating factor. Yes. Then number four, by applying the linear equation method. Yes, by applying the linear equation method. Now, basically, these are the four methods of solving or analyzing a first order differential equation. So I'll be using this ODE to designate or represent ordinary differential equation in this class. Yes, so these are the methods. Now we have seen the different methods of solving ODE, and of course the definition of a differential equation. So we are going to be looking at method number one. Yes, method number one. That is applying separating of variables method. Yes, separating of variable method. So now we have some questions here. Yes, now we're asked to solve the following ODE using separation of variables. Now let's look at question number one. Yes, question number one. Now, question one, solution. Yes, now the question is the y all over the x. The y all over the x is equal to, we have y squared plus xy squared all over x squared y minus x squared. Now remember I said we are looking at the separation of variables. Yes, we are using the separation of variables method. Yes, so that is the first method we're going to be looking at. Now in this case, we're giving the y all over the x is equal to y squared plus xy squared divided by x squared y minus x squared. Now it means in this case, the y all over the x is the same as saying, if you look at the numerator, you will discover that y squared is common. And because y squared is common, it means we can factor out y squared. So here we have y squared out. Here we'll be left with 1 plus x. Yes, 1 plus x. Because if you multiply y squared times 1, it will give y squared. And y squared times x, it will give xy squared. So we have factored out y squared. Now, all over. Now, looking at the denominator, we discover that x squared is common. And because x squared is common, we have to factor out x squared. So x squared, now in brackets, we'll be left with y here. Minus, here we have 1. Yes, minus 1. So now, that is the y dx. So now, it therefore means that here, yes, it means that the y all over the x, will be equal to, we have y squared in brackets, 1 plus x, all over x squared in brackets, y minus 1. So here, the variables involved in this equation are x and y. Yes, they are the two variables that are actually involved in the equation. So now we want to separate them. Yes, that is what the method is all about. Method of separating variables. So it therefore implies that here, now we have the y all over the x will be equal to, here this is the same as saying y squared all over y minus 1. Then here we have 1 plus x all over x squared. Yes, now I've separated this now. Look at y squared all over y minus 1 times x plus 1 all over x squared. Now, it therefore means that here, y minus 1 all over y squared, the y, is equal to, here we have 1 plus x all over x squared, then here we have the x. Now, let me explain. Now, in this case, if you multiply through by y minus 1, we have minus y minus 1 all over y squared, the y is equal to x plus 1 plus x all over x squared, then here we have the x. Now, integrating both sides. So it means here we have integral y minus 1 all over y squared, the y is equal to, yes, please, this is the y, is equal to integral 1 plus x all over x squared, then here we have the x. Yes, we have the x. So it therefore means that here we have integral in brackets y all over y squared minus 1 all over y squared, the y is equal to integral, here we have 1 all over x squared plus x all over x squared dx. Yes. So it therefore means that here, the left hand side, we have integral 1 all over y squared is 1 all over y minus 1 all over y squared. Now I take it again. Y all over y squared. This one here is 1. Y into y squared is y. Yes. Then here we have minus 1 all over y squared. So here we have the y is equal to integral 1 all over x squared plus, now this x will cancel this x squared. X into x is 1. And x into x squared is x. Then here we have the x. Yes. So moving forward, this is the same thing as saying, integral 1 all over y minus y raised to the power of minus 2. Now, 1 all over y squared is the same thing as y raised to the power of minus 2. So here we have the y. Yes, we have the y. Is equal to, this is the same as saying integral 1 all over x squared. Yes, 1 all over x squared. Now, this 1 all over x squared is the same thing as saying x raised to the power of minus 2. Yes, x power minus 2. Then we have plus 1 all over x. Then here we have dx. Now, if we integrate 1 all over y, it gives ln y. Yes, the integral of 1 all over y is ln y. So here we have minus. When you integrate this y power minus 2, it becomes y raised to the power of minus 2 plus 1 all over minus 2 plus 1. Now this is equal to, when you integrate x power minus 2, we have x power minus 2 plus 1 all over minus 2 plus 1. Then here we have plus ln x. Yes, because the integral of 1 over x is ln x. Then here we have plus constants. So it therefore means that here ln y minus y raised to the power of minus 2 plus 1 is minus 1. All over minus 2 plus 1 is minus 1. Is equal to x raised to the power of minus 1, because minus 2 plus 1 is minus 1. All over minus 1. Then here we have plus ln x plus c. Yes. So this is the same thing as saying ln y minus. Now let's look at this now. There's minus here and there's another minus here. Minus divided by minus is plus. Now this y raised to the power of minus 1 is the same thing as 1 all over y raised to the power of 1. Yes. Now this is equal to, we have minus 1 all over x raised to the power of 1 plus ln x. Then here we have plus c. Yes. So it therefore means that ln y, now if you bring this plus ln x inside to the left hand side, it becomes minus ln x. Yes, minus ln x. Now let's take this to the other side. So this will be minus 1 all over x plus 1 all over y to the other side. It becomes minus 1 all over y. Then we have plus c. So it therefore means that ln in brackets y all over x. Yes, because from the law, one of the laws of logarithm, we said when you have subtraction, you divide. So it means we have ln y all over x will be equal to minus 1 all over x minus 1 all over y. Then here we have plus c. Yes, so it therefore means that we can express this as ln y all over x plus 1 all over x plus 1 all over y is equal to c. So this is the solution to this particular question. So c, the value of our c is equal to the whole of this. That is ln y all over x plus 1 all over x plus 1 all over y is equal to c. So that's question number 1. Now I want us to look at question number 2. We have x squared in bracket y plus 1 plus y squared in bracket x minus 1, the y dx is equal to 0. Now solution. Yes, so remember we are still using the separation of variables method to solve the equations. So now in this case, let's look at this now. Y squared in bracket x minus 1, the y all over the x will be equal to, now this is plus x squared in bracket y plus 1. Taking it to the other side, yes, taking it to the other side, we have minus x squared in bracket y plus 1. Yes, minus x squared in bracket y plus 1. Now in this case, now let's look at this now. Yes, let's divide this side. Let's divide through by y plus 1. Yes, let's divide through by y plus 1. Now dividing through by y plus 1, we have y squared in bracket x minus 1, the y all over the x, all over y plus 1 will be equal to, we have minus x squared in bracket y plus 1, all over y plus 1. So at this point, This y plus 1 will go with this y plus 1. So here we'll be left with y square all over y plus 1 times we have x minus y 1. The y all over the x is equal to minus x squared. Now let's divide through again. Let's divide through by x minus 1. Yes, let's divide through by x minus 1. So it means here we have y squared all over y plus 1. Yes, dots. Here we have x minus 1 divided by x minus 1. The y all over the x is equal to minus x squared all over x minus 1. Yes, all over x minus 1. Now let's look at this. X minus 1 will go with x minus 1. So we have y squared all over y plus 1. The y all over the x will be equal to, we have minus x squared all over x minus 1. Yes, all over x minus 1. So now let's multiply through by the x. Now multiply through by the x. So if we multiply through by the x, it means here we have y squared all over y plus 1. The y all over the x times the x is equal to minus x squared all over x minus 1 dots times the x. Dots the x times the x. So it means in this case, this the x will go with this the x. Yes, the x will go with the x. So here we'll be left with y squared all over y plus 1. The y is equal to minus x squared all over x minus 1. Then here we have the x. Yes, we have the x. Now let's look at this now. Let's look at looking at the left hand side. Looking at the left hand side. So for the left hand side we have y squared. Yes, we have y squared divided by y plus 1. And this is the same thing as saying, here we have y squared and we have y plus 1. Yes, y plus 1. Yes. So in this case, now let's begin. Y into y squared is y. Y times y is y squared. Y times 1 is plus y. So the whole of this now will be y squared minus y squared is 0. So 0 minus y is minus y. Sorry, yes, minus y. Now I take it again. Y into y squared is y. Y times y is y squared. Y times 1 is plus y. Yes. Now let's begin. 1 into minus y is minus 1. Minus 1 times y is minus y. Minus 1 times 1 is minus 1. So it means the whole of this minus this is 0. 0 minus minus 1, that will give us 1. Yes, that will give us 1. So it therefore means that y squared divided by y plus 1 is equal to, now this is the quotient. So that will be the quotient, y minus 1 plus 1 all over y plus 1. Yes, so that's the value of y squared divided by y plus 1. Now let's figure the integral of it. So integral y squared all over y plus 1 the y. This will be equal to integral y minus 1 plus 1 all over y plus 1. Yes, everything here, we have the y. So when you integrate y minus 1, it gives us y squared all over 2 minus y plus, when you integrate 1 all over y plus 1, that will give us ln y plus 1. Yes, ln y plus 1. So this is for the left hand side. Now let's look at the right hand side. Yes, let's look at the right hand side. Now for the right hand side, we have minus x squared all over this. So let's just pick x squared. Let's look at x squared all over x minus 1. And of course, this is the same thing as saying x squared divided by x minus 1. So x into x squared is x. X times x is x squared. X times minus 1 is minus x. So now this is the same thing as saying x squared minus x squared is gone, that's 0. So here there's nothing here. So we have 0 minus x. That will be plus x. Yes, that will be plus x. So now x into x now is plus 1. 1 times x is x. 1 times minus 1 is minus 1. So here this is the same thing as saying x minus x is gone. 0 minus 1, that will give us 1. So it therefore means that x squared divided by x minus 1 is the same thing as saying the quotient. And the quotient is x plus 1, then plus the remainder, which is 1, all over x minus 1. Yes. Now integrating the right hand side. Now integrating x squared all over x minus 1. Yes, it will be integral of x plus 1 plus 1 all over x minus 1. Yes, then the whole of this we have dx. So when you integrate this, when you integrate x plus 1, when you integrate x plus 1, it will give x squared all over 2. Then here we have plus x. Then here we have plus ln x minus 1. Then we have plus constant. Yes, plus constant. Then remember, recall that left hand side is equal to right hand side. So for the left hand side, we actually got this. Yes, for the left hand side, we have y squared all over 2 minus y plus ln y plus 1. Now it will be equal to, now for the right hand side, yes, for the right hand side, we have x squared all over 2 plus x. Yes, we have minus x squared all over 2 plus x plus ln, here we have x minus 1 plus c. Okay, x minus 1 plus c. Yes, so here we have x ln x minus 1, then here we have plus c. Yes, plus c. Yes, plus c. So it therefore means that in this case, this is the same as saying we have ln y plus 1, yes, plus y squared over 2 minus y is equal to, here we have minus x squared all over 2 minus x minus ln x minus 1, then here we have plus c. Yes, we have plus c. So it therefore means that here, what we have now, let's call this, now the whole of this now, this minus will change this to minus c. Okay, so this c is an arbitrary constant. So it means we can decide to change this as ln y plus 1 plus y squared over 2 minus y is equal to minus x squared over 2 minus x minus ln x minus 1 plus c1. Yes, since c is an arbitrary constant, so now we are changing it to c1 because c1 is also a constant. So now it means in this case, this is the same as saying ln y plus 1. Now if you bring this plus to this other side, it will be this minus to this side will be plus ln x minus 1. Yes, so this times this, then here we have plus y squared all over 2. Yes, y squared all over 2 plus x squared all over 2. Yes, then here we have minus y plus x. Now the whole of this is equal to c1. So this is the same as saying ln y plus 1 x minus 1 plus y squared all over 2 plus x squared all over 2 minus y plus x is equal to C1. So here I want us to multiply through. Let's multiply through by 2. Yes, let's multiply through by 2. So multiplying through by 2, we have 2 ln, we have y plus 1, x minus 1 plus, here we have 2 in bracket y squared all over 2 plus 2 in brackets x squared all over 2, yes, minus 2 in bracket y, that's 2 times this now, then plus 2 in bracket x is equal to 2 times C1. So it means the whole of this now will be equal to, we have 2 ln y plus 1 x minus 1, please, this is minus, yes, x minus 1, then here we have plus, these 2 will go with this 2, we have y squared plus, these 2 will go with this 2, we have x squared minus, here we have 2y plus 2x is equal to, now let's call this a because this is another constant. So it therefore means that the whole of this now will be, we have x squared plus, or let's start with y squared, we have y squared plus x squared plus 2y, yes, plus 2y, okay, here this is minus 2y plus 2x, then we have plus 2 ln y plus 1 x minus 1 is equal to a. So this is the solution to this differential equation using separating the variables method. Yes, so that's question number 2. Now we're going to move straight to question number 3. Yes, let's look at question number 3. Yes, so we have seen question number 1, question number 2. Now let's look at question number 3. Now for question number 3, we have 1 plus x cubed. 1 plus x cubed is equal to, 1 plus x cubed, the y all over the x is equal to x squared. Then here we have y is equal to x squared y. So this is the same thing as saying now solution. Yes, this is the same thing as saying, bringing this y here, we have 1 all over y. The y is equal to, here we have x squared all over 1 plus x raised to the power of 3. Then here we have the x. So we have separated the variables. Yes, we have separated the variables. So here, let's look at the right hand side. Yes, let's look at the right hand side. Or before that, let's look at integrating both sides. Integrating both sides. Now that will be integral 1 over y dy is equal to integral x squared all over 1 plus x power 3. Then here we have the x. Yes. Now for the left hand side, when you integrate 1 over y dy, yes, it gives ln y. Yes, it gives ln y. So let's look at the right hand side. Yes, let's look at the right hand side. Now we have seen the left hand side. Let's look at the integral at the right hand side, since we have seen that on the left hand side. So now right hand side. Now integral x squared all over 1 plus x raised to the power of 3 dx. So now let's solve this now. Let's integrate this. Now in this case, let u be equal to 1 plus x raised to the power of 3. Yes. And if u is equal to 1 plus x raised to the power of 3, it means the u all over the x will be equal to 3x raised to the power of 2. Yes, it will give us 3x raised to the power of 2. And the u will be equal to 3x raised to the power of 2. Then here we have the x. So therefore means that the whole of this integral x squared all over 1 plus x raised to the power of 3 dx will be equal to integral, we have x squared all over, the whole of this is u, then dots, the u, the x here is the u all over 3x squared. Yes, let's look at it. All over 3x squared. Yes, that's the value of our dx. So now, this x squared will go with this x squared. It means we'll be left with 1 all over 3. Because 1 over 3 is a constant, so we're taking it out. Integral 1 all over u, then here we have the u. So here this will give us 1 all over 3 ln u plus constants. Yes, but remember the value of our u. We said let u be equal to 1 plus x raised to the power of 3. Yes, let u be equal to 1 plus x raised to the power of 3. So it therefore means that integral x squared all over 1 plus x power 3 dx will be equal to, we have 1 all over 3 ln u. And the value of our u is 1 plus x raised to the power of 3. Yes, so here we have plus c. Yes, so remember, recall, left hand side is equal to right hand side. Now for the left hand side, we have ln y. So here, ln y is equal to, now for the right hand side, we have 1 all over 3 ln 1 plus x raised to the power of 3. Then here we have plus c. Yes, and of course this is the same as saying ln y is equal to ln 1 plus x raised to the power of 3 all power 1 over 3. Then here we have plus c. Yes, and this is the same as saying ln y is equal to ln the cube roots. Yes, the cube root of 1 plus x raised to the power of 3. Then here we have plus c. Now let's bring this to this other side. So we have ln y minus ln the cube roots of 1 plus x raised to the power of 3 is equal to c. Yes, so going by one of the laws of logarithm, since here we have subtraction, but this is the same as saying ln, yes, y divided by the cube roots of 1 plus x raised to the power of 3 is equal to c. Yes, it's equal to c. And we all know that this ln here is the same as saying log to base e in brackets y all over the cube roots of 1 plus x raised to the power of 3 is equal to c. Now remember the definition of logarithm of a number to a given base. We said the logarithm of a number to a given base is the power to which the base can be raised to give the number. So it therefore means that here, this is the same thing as saying, y all over the cube roots of 1 plus x raised to the power of 3, yes, is equal to e raised to the power of c. Yes, e raised to the power of c. So this is another constant. Yes, this is another constant. So we can equally say our y is equal to e raised to the power of c times the cube root of 1 plus x raised to the power of 3. So since e raised to the power of c is an arbitrary constant, we can call this y is equal to a dot the cube root of 1 plus x raised to the power of 3. So this is the equation. Yes, so that ends question number 3. Yes, that ends question number 3. So we have seen question number 1, we have seen question number 2, question number 3. Now let me start this. Yes, let me start this. Now let's do a question number 5. Yes, let's do a question number 5. Now for question number 5, yes, for question number 5, we have cos y plus 1 plus e raised to the power of minus x. 1 plus e raised to the power of minus x. Then here we have sine y, the y all over the x. The y all over the x is equal to 0. Yes, it's equal to 0. So this is the same thing as saying 1 plus e power minus x, yes, sine y, the y all over the x will be equal to, if you take cos y to the other side, we have minus cos y. Yes, we have minus cos y. So it therefore means that here, this is the same thing as saying, now let's divide both sides by cos y. Yes, let's divide both sides by cos y. Now, dividing both sides by cos y. Now, divide via by cos y. So it means we have 1 plus e power minus x. Here we have sine y. The y all over the x. Yes, this is the y place. The y all over the x. Divide by cos y is equal to minus cos y all over cos y. Yes, minus cos y all over cos y. So it therefore means that here, now this is the same thing as saying 1 plus e power minus x. Then we have sine y all over cos y. The y all over the x is equal to minus cos y divided by cos y is minus 1. Yes, it's minus 1. Yes, that's the value. Cos y divided by cos y is 1. So minus cos y divided by cos y will give us minus 1. So it therefore means that here, what we have here now will be equal to, let's divide through again. Let's divide via by 1 plus e raised to the power of minus x. So it means here we have 1 plus e power minus x. We have sine y all over cos y. The y all over the x. Everything here all over 1 plus e power minus x. Now this is equal to minus 1 all over 1 plus e raised to the power of minus x. So now this 1 plus e power minus x will go with this. It means here at the left hand side, we have sine y all over cos y. The y all over the x will be equal to, we have minus 1 all over 1 plus e raised to the power of minus x. Yes. Now we have separated the variables. X, the dependent, x, the independent variables at the right hand side, y, the dependent variable at the left hand side. So now, integrating both sides. Integrating both sides. Yes. So integrating both sides, we have integral sine y. But before then, now since we have the x here now, let's multiply through by the x. Yes, let's multiply through by the x. So you tell them, multiply through by the x. So if you're multiplying through by the x, it means we have sine y all over cos y, the y all over the x, dot the x, that is times the x, is equal to minus 1 all over 1 plus e power minus x dot dx. Now this the x will go with this the x. I will be left with sine y all over cos y dy is equal to minus 1 all over 1 plus e power minus x. Then here we have the x. So at this point, we can integrate both sides. So now integrating both sides. Integrating both sides. So here we have integral sine y all over cos y, the y is equal to integral minus 1 all over 1 plus e power minus x. Then here we have dx. So now this is the same thing as saying integral sine y all over cos y dy is equal to minus integral 1 all over 1 plus e power minus x. Then here we have the x. Yes, we have the x. So it means at this point, let's look at the left hand side. Yes, let's look at the left hand side. Yes, the left hand side. So the left hand side, we have integral sine y. Let's integrate this. So let u be equal to cos y. Yes, let u be equal to cos y. So if u is cos y, it means the u all over the y, please, this is u, is equal to minus sine y. Yes. So here, our du will be equal to minus sine y. Then here we have the y. So it means the whole of this now will be integral. We have sine y all over cos y. So cos y is u. Then times the y. Now, if this is the u, yes, if this is the u, it means our dy from here, the y will be equal to, we have the u all over minus sine y. That will be the value of our dy. So it means in this case, our dy is the u all over minus sine y. Yes, all over minus sine y. So this sine y will go with this sine y. So we have minus integral 1 all over u du. So now when you integrate 1 over u, it gives ln u. So because of the negative sign here, we have it as minus ln u, which is the same as saying minus ln. The value of our u is cos y. So we have cos y. So it means we're done with the left hand side. Yes, now let's look at the right hand side. Yes, let's look at the right hand side. Now, this is the right hand side. Yes, this is the right hand side. So looking at the right hand side, it means what we have here will be integral. Yes, let's call it right hand side. Yes, right hand side. So for the right hand side, we are looking at minus integral 1 all over, we have 1 plus e power minus x, then here we have dx. Now let's look at this function. Let's look at 1 all over 1 plus e power minus x. So this is the same as saying 1 all over 1 plus 1 all over e raised to the power of x. Yes, because from indices, we said a raised to the power of minus x is the same as 1 all over e power x. So it therefore means that e power minus x is the same as 1 all over e power x. So it means the whole of this now will be equal to 1 all over, we have e power x, this times this plus this over this, plus 1 all over e power x. Yes. So now the reciprocal of this now will be e power x all over e power x plus 1. Yes. So that's the whole of this. So it means minus integral 1 all over 1 plus e power minus x dx is the same thing as saying minus integral e power x, yes, all over e power x plus 1. Then here we have dx. Yes, so this is the same as putting it this way. Yes, so minus integral 1 all over 1 plus e power minus x dx is the same thing as minus integral e power x all over e power x plus 1 dx. So now let's look at this now. So in this case, let u be equal to e power x plus 1. Yes, let u be equal to e power x plus 1. Yes, let u be equal to e power x plus 1. So it means what we have here now will be, if this is u. Now let's look at du all over the x. Du all over the x. Now when you differentiate e power x plus 1, it will give e power x. Yes, when you differentiate e power x, is e power x. When you differentiate 1 is 0. Yes, the derivative of 1 is 0 because 1 is a constant. So it means at this point, du all over the x is e power x. So our du will be equal to e power x dx. Yes, du will be e power x dx. So our dx will be equal to du all over e power x. Yes, the x will be du all over e power x. Now let's look at this. So it therefore means that in this case here, minus integral e power x all over e power x plus 1 dx will be equal to minus integral, we have e power x all over u, because we said let u be equal to e power x plus 1. Yes, so we actually tie e power x plus 1 to this to u. So it means this denominator here now will be u. Then times the x now is the u all over e power x. So this e power x will go with this e power x. So this will give us minus integral 1 all over u. Then here we have the u. So it means the whole of this now will be equal to minus ln u plus c. So that will be minus ln. Remember the value of our u. We say let u be equal to e power x plus 1. So here we have e raised to the power of x plus 1. Then here we have plus c. Yes. So remember, left hand side is equal to right hand side. Yes, left hand side is equal to right hand side. Okay. Left hand side, recall. Yes, left hand side is equal to right hand side. Yes. So for the left hand side, we have minus ln cos y. Now for the right hand side, we have minus. Yes, we have minus ln in bracket e raised to the power of x plus 1. Then here we have plus c. Yes, plus c. So it means at this point, there is the same as saying minus ln cos y plus ln e raised to the power of x plus 1 is equal to c. Yes, which is the same thing as saying because minus a plus b is the same thing as b minus a. So it therefore means that minus this plus this is the same as saying ln in bracket e power x plus 1 minus ln cos y. Now this is equal to c. Yes. Now for one of the laws of logarithm. Now when you have subtraction, we know we are dividing. So here this is the same as saying ln. Here we have e raised to the power of x plus 1 all over cos y is equal to c. Yes, it's equal to c. And we all know that this is the same thing as saying log e raised to the power of x plus 1 all over cos y base e is equal to c. So it means e raised to the power of x plus 1 all over cos y will be equal to, here we have e raised to the power of c. Yes, we said the logarithm of a number to a given base is any power to which the base can be raised to give you the number. So it means e power x plus 1 all over cos y is equal to e raised to the power of c. So it therefore means that here, what we have here now will be equal to, yes, what we have here now will be equal to, we have e raised to the power of x plus 1 all over cos y will be equal to, we said, e raised to the power of c. So this is an arbitrary constant. So we can call this e power x plus 1 all over cos y is equal to, now let's call it a. Yes, a is also a constant, an arbitrary constant. So it therefore means that when you cross multiply, we have e power x plus 1 is equal to a cos y. So making cos y the subject here, our cos y will be equal to, here we have e raised to the power of x plus 1 all over a. Or you can call this cos y is equal to 1 all over a in bracket e raised to the power of x plus 1. So to get the value of y, here, to get the value of y, our y, yes, our y will be equal to, the value of y will be equal to the cos inverse. Yes, the cos inverse of e raised to the power of x plus 1 all over a. Yes, which is the arbitrary, which is an arbitrary constant. Okay, so now this is the solution of question number 5. Yes, so as you can see, we have actually solved question number 1. Question number 2, question number 3, and of course question number 5. So I left question number 4 for you to do as an assignment. So please make sure you answer question number 4 and drop your question on the comment section. So thank you so much for listening. So that actually brought us to the end of solving first order differential equation using the separation of variables method. So thank you once more.